Dear students, in this module we are going to discuss about client server programming. First, let us have a look at network. What is meant by network? Well, interconnection of computers is called a network. A network can be formed by connecting hundreds of thousands of computers. For example, internet is the largest network in which millions of computers are connected. In a network, some computers receive data or services from other computers. The computers that receive services are called client machines. The computers which provide their services in the network are called server machines. For example, a computer requesting a file from another computer in the network is called a client, and the other computer sending the file is called a server. Both client and server machines need software to receive and send the data. We need a program at client side and another program at server side whose role is to establish communication between those computers. It is possible to establish logical connecting point between a server and a client so that communication can be done through that point. This point is called socket. Client server programming is also known as socket programming. Socket is the end point of a bidirectional communications channel between server and client. Sockets may communicate within a process, between processes on the same machine, or between processes on different machines. For any communication with a remote program, we have to connect through a socket port. Each server listens for clients calling on one or more ports. So, a port may be a fixed num port number, a string containing a port number, or the name of a service. A network socket is an endpoint of a two-way communication link between two programs or processes, that is client and server in our case, which are running on the network. This can be on the same computer as well as on different systems which are connected via the network. Both parties communicate with each other by writing to or reading from the network socket. The technical equivalent in reality is a telephone communication between two participants. The network socket represents the corresponding number of the telephone line or a contract in case of cell phones. One socket, that is node, listens on a particular port at an IP, while other socket reaches out to the other to form a connection. Server forms the listener socket while client reaches out to the server. So, what is server? Well, a server is a software that waits for client requests and serves or processes them accordingly. On the other hand, a client is requester of the service. A client program requests for some resources to the server and server responds to that particular request. In order to make use of the socket functionality, only the Python socket module is necessary. In the example code shown, the Python time module is imported as well as in order to simulate the weather station and to simplify time calculations. In this case, both the client and the server run on the same computer. A socket has a corresponding port number which is 2, 3, 4, 5, 6 in our case. If desired, you may choose a different port number from the unrestricted number range between 1024 and 65535. To use Python socket connection, we need to import socket module. Then sequentially we need to perform some task to establish connection between server and client. To create a socket, you must use the socket.socket method function available in socket module, which has the general syntax S is equivalent to socket of socket family, socket type and protocol equal to 0. Socket method create a new socket using the given socket family, socket type and protocol number. Socket family, this is either AF Unix or AF INET. Socket type, this is either SOC stream or SOC DG RAM, that is datagram. Protocol, this is usually left out, default value is 0. Once you have socket object, then you can use required functions to create your client or server program. We will create a socket object using socket.socket method and specify the socket type as socket.soc stream. When you do that, the default protocol that is used is the transmission control protocol, shortly called as TCP. Why should you use TCP? The TCP, that is the transmission control protocol, is reliable. Packets dropped in the network are detected and retransmitted by the sender. Has in order data delivery, that is data is read by your application in the order it was written by the sender. In contrast, user datagram protocol, shortly called as UDP, sockets created with socket.soc DG RAM are not reliable and data read by the receiver can be out of order from the sender's writes. Why is this important? Networks are a best effort delivery system. There is no guarantee that your data will reach its destination or that you will receive what is being sent to you. Network devices, for example, routers and switches have finite bandwidth available and their own inherent system limitations. They have CPUs, memory, buses and interface packet buffers just like our clients and servers. TCP relieves you from having to worry about packet loss, data arriving out of order and many other things that invariably happen when you are communicating across a network. A socket client requests for some resources to the socket server and the server responds to that request. So, we will design both server and client model so that each can communicate with them. The steps can be considered like this. Python socket server program executes at first and wait for any request. Python socket client program will initiate the conversation at first. Then server program will respond accordingly to client requests. Client program will terminate if user enters by message. Server program will also terminate when client program terminates. This is optional and we can keep server program running indefinitely or terminate with some specific command in client request. Once we have an initialized socket object, we can use some methods to open a connection, send data, receive data and finally close the connection. The syntax to connect to an IP with port could be sock.connect of IP address, second parameter is port number, here 8080. The syntax to send some data is socket.send of 25 bytes to send the message to be transmitted. So, syntax to receive up to 4096 bytes from a peer is sock.receive of 4096. The syntax to close the socket connection is socket.close method. After the execution of close method, no more data transmission takes place. Next, we will discuss about server socket methods. S.bind method. This method binds address of host name, port number pair to the socket. S.listen method. This method listen for communications made to the socket. X.accept method. The return value is a pair of connection address where connection is a new socket object usable to send and receive data on the connection, and address is the address bound to the socket on the other end of the connection. Let us move on to client socket methods. The first one is S.connect method. This method actively initiates TCP server connection. Apart from client and server socket methods, general socket methods are also available. One such method is S.receive method. This method receives TCP message. S.send method send data to the socket. The socket must be connected to a remote socket. It returns the number of bytes sent. Applications are responsible for checking that all data has been sent. If only some of the data was transmitted, the application needs to attempt delivery of the remaining data. S.receive from method. This method receives UDP message. S.send to method. This method transmits UDP message. S.close method. This method closes the socket. The remote end will receive no more data after queued data is flushed. Sockets are automatically closed when they are garbage collected, but it is recommended to close them explicitly by using socket.getHostName method. We can obtain the host address by using socket.getHostName function. It is recommended to use the port address above 1024 because port number lesser than 1024 are reserved for standard internet protocol. To write internet servers, we use the socket function available in socket module to create a socket object. A socket object is then used to call other functions to set up a socket server. Now, call the bind of hostname port function to specify a port for your service on the given host. The bind method denotes that the socket is bound to the IP address and the port number 23456. Next, call the accept method of the returned object. This method waits until a client connects to the port you specify and then returns a connection object that represents the connection to that client. Let us see how client and server communication takes place through flowchart representation. The left hand column represents the server, on the right hand side is the client. Starting in the top left hand column, note the API calls the server makes to set up a listening socket by calling the methods socket method, bind method, listen method and accept method. A listening socket listens for connections from clients. When a client connects, the server calls accept method to accept or complete the connection. The client calls connect method to establish a connection to the server and initiate the three-way handshake. The handshake step is important since it ensures that each side of the connection is reachable in the network. In other words, that the client can reach the server and vice versa. It may be that only one host, client or server can reach the other. In the middle is the round trip section where data is exchanged between the client and server using calls to send method and receive method. At the bottom, the client and server close their respective sockets. So, from the flowchart diagram, you would have learned what all socket methods required to create a client server socket program in Python. Socket programming is started by importing the socket library and making a simple socket. Here we made a socket instance and passed it two parameters. The first parameter is AF INET and the second one is sock stream. AF INET refers to the address family IPv4. The sock stream means connection oriented TCP protocol. Now we can connect to a server using this socket. We can find the IP of the server by using the get host by name method. Video 1. So, first thing is you have to import socket module. If it is successfully imported, then the print statement displays socket imported successfully. Then you have to specify the two parameters inside the socket method. Then you have to call the get host by name method. Inside you have to specify google.com, then print IP. If you run this module, then we will get the output as socket imported successfully. Then you will get the IP address of google.com. Let us write a very simple client that connects to a given host and port, reads any available data from the socket and then exits. The socket.connect of hostname comma port opens a TCP connection to hostname on the port. Once you have a socket open, you can read from it like any IO object. When done, remember to close it as you would close a file. Note that the server socket does not receive any data. It just produces client sockets. Each client socket is created in response to some other client socket doing a connect method to the host and port we are bound to. As soon as we have created the client socket, we go back to listening for more connections. Now run the server.py in the background and then run client.py to see the result. So here we are having server program first, import the socket module, then after that call the socket method to create the socket object, then specify the port number and bind the socket with the local host and the specified port number. Then if you want to display, then we can display the socket which is bounded to the corresponding port number by using the print statement. Now the socket is in listen mode. So we can display that socket is in listening mode. Then we have to bind the client with the specified address by calling the accept method. So once the client is connected or communicated with server, then we can get the connection message, that is got connection from the specified address. Then the server has to send the message to the client as thank you for connecting. Then it has to close the object by calling the close method. So the server program ends here. Next we move to the client program. So for the client program, the first step is to import the socket module. Then we have to call the socket method. So here the port number you have to specify. Here the port number is 12345. then the client program has to execute a method called connect by specifying the corresponding host name and port. According to this example, the local host itself is act as the host. Therefore, I will give the value as the loopback address 127.0.0.1 and the specified port number is 12345. So, once the connection is established, then the client program is now ready to receive in terms of 1024 bytes. This can be done with the help of calling the receive method s.receive of 1024. Once the process is completed, then client program must close its socket object by calling the close method. How to execute this particular client and server program? So, for execution, first you have to start the server in background by setting the command or by calling the command python server.py and ampersand symbol in the terminal. Open another terminal. After starting the server, now it is necessary to run the client program by executing the command python client.py. So, the output of this client server program will be on server side got connection from 127.0.0.1 and the port number, and on the client side thank you for connecting. Let us see some important modules in Python network or internet programming. Or the first protocol is HTTP. It is used for web pages. The port number is 80 and modules are HTTP LIB, URL LIB, XML RPC LIB. And for NNTP, it is Usenet News. The port number is 119 and the URL is NNTP library. FTP file transfer 20, FTP library and URL library. For SMTP, which is used for sending email, port number is 25 and library is SMTP lib file. POP3 for fetching email, port number is 110 and the library module is POP-lib. IMAP4 for fetching email, the port number is 143 and the corresponding library file is IMAP-lib. For Telnet, which is used for command lines, the port number is 23 and the module is Telnet-lib. For Gopher, for document transfer, the port number is 70 and the module is Gopher-lib URL lib. I hope that this module would have led you to learn something new about the Python socket programming. Let us summarize the concepts we learned so far. In this module, we discussed about the essence of network programming by creating client and server programs. It shows that Python programming takes a significant role in client server architecture, where the client makes data request to a server and the server replies to that machine. I hope you understand the concept well. See you again in next module. Thank you.